Let's continue with it. We have done if A and B are invertible matrices of the same order, then AB inverse is equal to B inverse into A inverse. Now here are some notes. If A is an invertible matrix, then A transpose is also invertible. एंड ए ट्रांसपोज का इन्वर्स क्या होगा हमारे पास, ए इन्वर्स ट्रांसपोज. सेकंड इज इफ ए इज invertible, then inverse of A inverse is equal to A power K inverse is equal to A inverse power K, where K belongs to N. The third one is determinant of A inverse is equal to 1 upon determinant of A. नेक्स्ट आपके पास सिस्टम ऑफ इक्वेशन एंड क्राइटेरिया फॉर कंसिस्टेंसी. It is called as Gauss-Jordan method. Let's take an example. a1x plus b1y plus c1z is equal to d1. a2x plus b2y plus c2z is equal to d2. a3x plus b3y plus c3z is equal to d3. This implies that a1x plus b1y plus c1z, a2x plus b2y plus c2z, a3x plus b3y plus c3z is equal to d1, d2, d3. And we can write it as a1 b1 c1, a2 b2 c2, a3 b3 c3 is equal to x y z equal to d1 d2 d3. Okay, this implies that ax is equal to v, and this implies pre-multiply by A inverse on both sides. So A inverse ax is equal to A inverse b if determinant of A is non-zero, and it will implies x is equal to A inverse b, which is equal to adjoint of A divided by determinant of A into B. Now some notes. First is if determinant of A is non-zero, system is consistent, having unique solution. Second is, if determinant of A is non-zero and adjoint of A into B is not null matrix, system is consistent, having unique non-trivial solution. Third is, if determinant of A is non-zero and adjoint of A into B matrix is equal to null matrix, then system is consistent, having trivial solution. Next is, if determinant of A equal to 0, then the matrix method fails. And in this, if adjoint of A into B equal to null matrix, then the infinite solution or no solution. If adjoint of A into B is not null matrix, then inconsistent, means no solution. So the matrix chapter is over here.